Almost 100 years ago, Henry Gantt came up with the Gantt chart, which we still use today. In the 1950s and 60s, we saw a lot of growth in project management as a discipline and in the growth of analytic methods in project management. And this was because of a lot of the defense and aerospace programs around that time, like the Apollo project, for instance, and a lot of other defense-related programs. The American Association of Cost Engineers was founded in 1956. The IPMA and the PMI, the two largest project management societies in the world, were founded in the 1960s as well. Analytic methods such as the critical path method, the PERT diagram, and so on date from that time period as well. In the 1980s, we start seeing more and more application of computers for project management. We see the launch of what became Oracle Primavera and MS Project in the 1980s. These are still used today to manage capital projects in our industry, the oil and gas industry. And in more recent years, we've kind of seen like how this is moving to the cloud. So essentially, these computer-aided methods are still implementing these earlier methods. So we still visualize schedules in the form of Gantt charts and PERT diagrams. We use the critical path method and so on. There is a lot of limitations to this approach. One is that these are all estimates and activities that are planned within a project. And within project planning has limitations in terms of forecastability because of complexity. There is also limitations because of cognitive biases, because we do underestimate time and cost. And again, this proliferates across these networks. The other thing, of course, is principal agent issues, where there is a deliberate element to understating costs and time as well across contractual networks. So AI and machine learning will help because it helps you to look at the track record of previous projects in order to correct the errors that are made in project estimates. And it also allows you to look at the project networks, and these are complex networks, and try to understand the nature of risk, how risk is built up, how it flows, and predictive analysis of how risk can build up in a project and how it can affect your cost and schedule outcomes. In the future, blockchain is going to be a transformational force in project management when it matures in the coming years. So I will be focusing on a machine learning method for project forecasting, and I will talk briefly about some of the methods. So this is what is called reference class forecasting. So the recommendation by Kahneman and Tversky to look at the track record of past projects in order to correct in-project estimates was developed into a methodology called reference class forecasting by Professor Ben Flubier, who is one of the world's predominant experts on mega projects. So how does it work? So this is a cumulative probability distribution that was generated from the track record of offshore projects that we saw earlier. So essentially what you have on the y-axis is uplifts, project uplift to schedule and cost. And on the x-axis, you have the probability of cost or schedule overrun. So if you have a 0% uplift to your schedule on an offshore project and during FID, according to this chart, 0% uplift would result in approximately a 75% probability that you're going to have a schedule overrun. And similarly for the cost, you would a 0% uplift is correlated with approximately 85% chance that you'll see an overrun. So the way that you would use this to manage your risk is to uplift your schedule and cost estimates. If you were to work with a 50% or less probability of your project exceeding its schedule, if you wanted a 50% or less probability of your project exceeding your schedule, you would do a schedule uplift of approximately 20% because that is the track record of offshore projects. And this is essentially, this distribution points to the deviation of actual cost and schedule from planned cost and schedule. So any offshore project would be subject to this curve.